When physics and AI meet, great things happen. In this video, I am introducing you to this new project called as PhysDream. PhysDream allows you to have physics-based interaction with 3D objects. Let me play this video and you will understand more what I mean. This is a 3D object which is AI generated and we are poking it in different directions and you can see that it is so realistic. It seems that someone is interacting with these objects, whether it is a wind or with some sort of poking by hand or by some object. How realistic and good it looks. Now, realistic object interactions are crucial for creating immersive virtual experiences, yet synthesizing realistic 3D objects dynamic in response to novel interaction remains a significant challenge for anyone out there. Realistic object interactions play a very important role in creating immersive virtual experiences. Recent advances in 3D vision have enabled the capture and creation of high quality static 3D assets, and some methods even extend to 4D assets, generating unconditioned dynamics. But these approaches cannot handle interactive action condition dynamics, which is crucial for synthesizing realistic object response to new interactions such as external forces or agent manipulations. Action condition dynamics differ from an unconditional and text condition dynamics in that it requires perceiving the physical material properties of objects and grounding the 3D motion predictions on these properties, such as object stiffness. Yet, estimating physical material properties is a challenging task due to the lack of ground truth data, as measuring these properties for real objects is highly difficult. Real objects often exhibit complex, spatially varying material properties, making the estimation problem even more challenging. If you look at this diagram, this gives you another view into this awesome project. So if you look at the left, it is leveraging and distilling prior knowledge of dynamics from a pre-trained video generation model. And these researchers have estimated a physical material field for the static 3D objects, which is on the left. And then on the right, the physical material field allows synthesizing interactive 3D dynamics under arbitrary forces. And they show rendered sequences from two viewpoints with red arrows indicating force directions. Coming back to our project page, let me show you an interactive gallery which is very interesting. This interactive gallery is showcasing their results in synthesizing interactive motions for 8 objects. The drawn circles and arrows roughly indicate the area and direction of applied force. So the circles are for illustrative purposes only and they're not drawn precisely, but rest of it is quite precise as you can see. Now this is the static point in force A. Let me click on force B. This is the force B. Again, this is force A in this direction and upward is force B. If I show you, let me go to force A and then moving point. See, it is moving now. Let it move. You saw the force A. Again the force A. Let me select force B. Now it is moving and it is force B. Amazing stuff. Let's check out another example. So I'm just clicking on the top. You see again moving and it is just a phone cable. There you go. It is just swirling in this direction. Let go static. There you go. How good is that? This is a force A. Let's check out another example. Again, similar thing. This is a static one. Looks so real. There you go. This we already have seen. And this is a flower one which was in different direction from the same viewpoint. And this is a moving one. And check out this. Again, the force is again sort of a downward towards the end. There you go. And you can see, how the branch is bending. is that. Also, the leaves are moving. There you go. Just keep an eye on the bend of the branch here. And this is the force. And similarly, if you look at it, this is again yet another demonstration of this amazing project. Now, so the researchers in this paper have focused on synthesizing interactive 3D dynamics, and their goal is to transform static 3D objects into interactive ones that can respond to new interactions in a physically plausible manner. And that is where they have proposed this Phys Dreamer, which is a physics based approach that leverages the object dynamics priors learned by video generation models. The key idea behind Phys Dreamer is to distill these priors to estimate the physical material properties of static 3D objects. And they hypothesize that video generation models trained on large amount of video data implicitly capture the relationship between object appearance and dynamics. By leveraging this learned prior knowledge, FishDreamer can infer the physical material properties that drive the dynamic behavior of objects even in the absence of truth material data. The FishDreamer represents 3D objects using 3D Gaussian models and also models the physical material field with a neural field and simulate 3D dynamics using the differentiable material point method or MPM as it is commonly known. The differentiable simulation and rendering allow for direct optimization of the physical material field and initial velocity field by matching pixel space observation. And they focus on elastic dynamics and showcase fish streamer through diverse real examples such as flowers, plants, and a beanie hat and a telephone cord as we just saw. And they have also evaluated the realism of the synthesized interaction motion through a user study. And they have a full research evaluation findings in this paper. I will drop the link to this project page in video description, and I would highly suggest that you read through it. It's very, very nicely and written in a very easy language. And finally, if you look at this example, they have done this visual comparison between this Fizz Dreamer synthesized video's real captured footage and baseline method. And baseline is Dream Gaussian 4D, Fizz Gaussian, and few others. So you see, just focus on this real capture and theirs. So it seems that there is looks more realistic than the real capture one. Whereas Fizz Gaussian and Dream Gaussian are not that good. I mean, especially Fizz Gaussian is totally off. Anyway, so that's it guys. I hope that you enjoyed it. Let me know your thoughts. If you like the content, please consider subscribing to the channel. And if you're already subscribed, then please share it among your network as it helps. Thanks for watching.